All right, no time. Let's take a good look at this question. Look at this question. Question 10. Look at the figure 2.35. It shows a diver immersed in a large body of water with a refractive index of 1.33. When he looks up, he can see a circular disc of light from above. The radius of the circle is 2 meters. A. What is the critical angle of the water? B. How deep is the diver? C. How deep would the diver appears to be when viewed from above? It's a very simple question. All right, let's illustrate this. This is under what? Refraction of light. When light bend or wave, when the rays of light bend from one medium to another medium. This medium is air, while this medium is what? Water. So this is the what? The critical angle. This is the critical angle. This is the radius. Radius is what? 2 meters. All right, this is the diver. This guy here, the diver. So what are we given in the question? We're given refractive index of water, which is 1.33 of visible light. This is the refractive index of visible light. Then we're given radius. Radius as what? 2 meters. We are looking for what? Critical angle. Critical angle. Okay, that is yes. I have it here. All right. We are going to do this using what? Using what? To get the critical angle, we are going to use Snell's law under what? Critical angle, because Snell's normally explain a lot about what? Bending of what? Light ray. Okay. So this is what? Using use of what? Snell's law. We are looking for the what? The angle, that is sine theta. Sine of the critical angle is equals to, we have what? Refractive index of air over what? Refractive index of water. The refractive index of water is what? 1.33. Refractive index of air. So what is the refractive index for air? Remember, for critical angle only happens when the refracted ray, the angle of the angle of refraction is what? 90 degree. Angle of refraction is what? 90 degree. So the light ray bend right here from this medium to another medium. It means that the angle here, angle of refraction for air here is what? 90 degree. And sine 90 degrees is what? 1. So therefore, the refractive index of air is what? 1, because the angle here, angle right here is what? Is a critical angle. Critical angle, that means the angle of refraction is what? 90 degree. So therefore, I have sine the critical angle is equals to, of air is what? 1. Let's say 1.00 over what? 1.33. We are looking for the critical angle. So therefore, sine the critical angle is equals to, so if I say divided by 1.33, I'm going to have, this is approximately 0.7519. Approximately 0.7519. So therefore, I'm looking for the critical angle. So therefore, critical angle is equals to what? Sine inverse of 0.7519. Sine inverse of this, we are going to have, that is the critical angle is equals to what? 48.75. 48.75. Ladies and gentlemen, this is the what? Critical angle. Okay, question 2. Question 2 says, how deep is the diver? How deep is the diver? So therefore, this angle right here is what? 48.75. How deep is the diver? The diver is right here. How deep is the diver? So therefore, we are looking for this what? This length. That's the depth. We are looking for this. Let's call this the heights. How deep is the diver? If you look at this diagram very well, this is a right angle triangle. 90-degree right here. This is a right angle triangle. We are looking for what? The adjacent. Remember that the adjacent line is the line on which the 90-degree angle and the given angle lies on. That is the what? The adjacent. So we are looking for what? Adjacent. It's a very simple something. You don't need to stress yourself. How deep is the diver? This is what we are looking for. So therefore, we are going to use tan. We are going to use tan. Why are we using tan? We have opposites. We are looking for adjacent. We have opposites. We are looking for what? Adjacent. Which trig function have opposites and adjacents? If you look at it very well, so, car, toi. Which one have opposite and adjacent? Is this one. So we are using what? Tan. So therefore, I will say tan theta is equals to what? Opposite over what? Adjacent. Opposite over adjacent. Opposite over adjacent. So therefore, tan theta is what? 48.75 equals to opposite is what? 2 over what? Adjacent. That is the height. That's what we are looking for. So therefore, the height is equals to what? 2 over what? Tan 48.75. So the height becomes what? This is 2 over tan 48 point tan 48 point what? 75. That is what? 1 point what? 1.140. What I have here is what? 1.14 what? 0. So therefore, what is the height? The height becomes, that is 2 divided by what? The answer. That is 1 point what? Let's approximate to 1 point what? 75 what? Meter. This is the what? Height. Okay. Then what next again? Question 3. What's the question? 220. Question 3 says, C. How deep would the diver appear to be when viewed from above? When viewed from above. How deep will it be when viewed from above? It's like somebody is here. Let's assume that somebody is here. You want to view this diver that is inside the water from above. From outside the water, you want to view the diver when viewed from above. Outside, this is another medium, the air. This is another water. You will not have the same depth. It's impossible. You will not have the same depth. How deep is the diver? This is how deep is the diver. But when you view it from above, it's going to be different. Just like somebody is in a pool. In a pool now, you stand outside the pool, you are looking at someone in the pool, someone inside the pool. The depth is going to do what? Reduce. Due to what? Refraction of light. The depth is going to reduce due to what? Refraction of light. It shows that what? Light bends. But when you enter the pool, you discover how deep it is. But from outside, you view, you can't get the actual what? Depth. Okay. So therefore, to get this, we are going to use what? The refractive index. I'm going to clean this side of the board. Okay. We are going to, where should I clean now? Let me clean in this side. You can always pause the video and put the note there. Still using Snell's law. This is what? Read depth. The read depth over what? Over apparent what? Depth. Read depth over what? Apparent depth. The real depth is the what? The actual depth. The apparent depth is the one when viewed from outside. That's what we are looking for. Why this is the refractive index of what? Water. So therefore, we are looking for what? The apparent what? Depth. We already have the real depth. So let's look for the what? Apparent depth. Apparent depth, make it a what? A subject is equals to what? The real depth over what? Refractive index water. So therefore, the apparent depth is equals to the real. Real is what? 1.75 over is 1.33. So what's the apparent depth? Apparent depth, that is 1.75 divided by what? 1.33. So I have what? 1.3, approximately 1.32 what? Meter. So these are answer for what? Apparent depth. You can see the apparent depth 1.32, but the real depth is what? 1.75. So when you view from outside the pool, it's like the depth of the person reduce. It reduces because of what? The refraction of light. Light has